Here's something that trips up a lot of people studying OSPF, including me the first time I saw it. Type 3 LSA is called the Summary LSA, and the natural assumption is, oh, it must be about route summarization. Aggregating routes, maybe? Making things smaller? It's not even close. The name is genuinely misleading. And once you understand what it actually means, the answer to who generates it becomes completely obvious. Let's get into it. So here's the question we're going to answer today. This is a real exam question. It shows up on CCNA, shows up on CCNP, and it's the kind of question where if you just memorize an answer, area border router, you'll get it right on the exam, but you actually won't understand why. And understanding why is the whole point of this. So we're going to talk through it. Think about it together, and then I'm going to show you the answer live in a lab. No guessing, actual evidence. Let's start with the setup. So picture this topology. 3 routers. Router 1 is sitting in area 1. Router 3 is in area 0. That's the backbone area. And router 2 is in the middle, with one interface in area 1 and one in area 0. Now, why does OSPF even have areas at all? Because a flat, single area OSPF network doesn't scale. If you've got hundreds of routers, every single one of them has to store every other router's link state advertisement and run Dijkstra's SPF algorithm against all of it. That's a lot of computation, a lot of memory, and every time a link anywhere flaps, the whole domain reconverges. Areas fix them. You put a fence around a chunk of the network. Topology information stays inside of the fence. Routers outside Area 1 don't need to know every link inside Area 1. They just need to know about what prefixes are reachable through Area 1 and at what cost. So now the question becomes, who's responsible for telling the rest of the network what's reachable inside of the area? That's the area border router. In our lab, that's router 2. It's the only router with a foot in both areas. It understands area 1's full topology. It understands area 0's full topology, and it's the one that bridges them. But here's the key thing. It doesn't just copy and paste area 1's information into area 0. That would defeat the entire point. If router 3 had to process all of area 1's type 1 and type 2 LSAs, we haven't actually isolated anything. Instead, the area border router does something specific. It runs SPF internally for each area, figures out which prefixes are reachable and at what cost, and then creates brand new advertisements or type 3 LSAs that describe those prefixes in simple format. Here's a network, here's a mask, and here's the cost to reach it from me. It regenerates the information. It doesn't forward it. And that's actually what the word summary is trying to tell you. Not route summarization, not CIDR aggregation. The ABR, the area border router, is summarizing, condensing all of the complexity of a full link state topology area into a simple, flat prefix advertisement. We'll come back to that naming confusion in a minute. First, let me show you all what's happening in real life. Let's dive into the topology, shall we? Okay, we are in EVE-NG, 3 Cisco IOSv routers, all wired up running OSPF. What we're going to do is start on router 2 because that is our area border router. So what I'll do is I'll kind of open this up a little bit so you can see it a little bit better. All right, and now what we're going to do is we're going to type show IP OSPF. Right, this is going to give us a ton of output. Right, so we'll just get through this and we'll scroll up as needed. Right. So the command gives us a summary of the OSPF processes on this router. And right here, what we're looking for, the number of areas is what we're looking for. The number of areas in this router is 2. Okay? And then what we're going to look for is we want something explicitly telling us what this router is. So if we scroll up, what we can see here, very clean and purely, is it is an area border router on router 2. Okay? iOS says it directly. It is an area border router, not an inference, not a guess. The router knows what it is. Now look at a breakdown below that. Area 0, we have 2 interfaces in this area, but 1 loopback. So area 1 also has 1 interface in it. Okay, router 2 has a presence in both. That's all it takes to be an area border router. So router 2 is our area border router. Now let's go and look to see at what router 1 sees. So what I'll do here is I will open up our router 1 so we can see it a little bit better. All right, and then what we'll do is we'll type show IP OSPF database. Okay, and as you can see, we have database entries for area 1 and area 1 only. So area 1 is an internal router. This router has no idea what area 0's topology looks like internally. So if we look at the database, we've got 2 sections here. The first one is router link states for area 1. Okay, as we can see very clearly here. These are type 1 LSAs, or link state advertisements. Every router in area 1 generates one of these about itself. You can see 1.1.1.1, that's router 1, that's us, and 2.2.2.2, which is R2. Both of them have their own router LSAs in this area, that's normal. Type 1 intra-area stays within the fence. Now here's the interesting part. So if we look at our net link states and summary net link states, these are the type 3 LSAs, all right? And look at the ADV router column. Every single entry shows 2.2.2.2, okay? Every one, not 3.3.3, not 1.1.1.1, only router 2. R1 can't generate type 3 LSAs. Why? Because it's not an ABR. All right, R3 can't generate type 3 LSAs for area 1. It's not in area 1 at all. Only router 2, which sits on the border, can create these. The database is showing you the answer. The ABR generates type 3 summary LSAs. Let's go a level deeper and actually look inside of one of these type 3 LSAs. So the command that we'll type is show IP OSPF database summary. Okay, this is going to give us a good amount of output, but what it does is it gives us a detailed view of every summary LSA in router 1's database. So let's walk through the fields on this first one. Let's look at our LS type. Okay, this is the summary links network, and that is iOS confirming this is a type 3 LSA. Now let's look at the link state ID. What do we see here? Well, this is the network address being advertised, a prefix from area 0 that router 1 would otherwise have no knowledge of. All right, so now we look at the advertising router, which we can see is router 2. So there it is again. Router 2 is every time. And then lastly, the network mask and the metric of 1. That's it. That's the entire content of this link state advertisement. No interface list, no neighbor table, no topology. Just here's a network, here's the prefix length, here's what it costs me, the area border router, to reach it. The receiving router takes that metric and adds it to its own costs to get to router 2. And that's the route cost you'll see in the routing table. OSPF is a link state protocol within an area, but in inter-area, it behaves more like a distance vector. And Type 3 LSAs are exactly why. Let's do one more confirmation. From Router 1's perspective, who are the border routers in this OSPF domain? Right, so the command that we'll run is going to be show IP OSPF, and what we'll actually type is border routers. Okay, right here, 2.2.2.2 is listed, labeled ABR. Lowercase I on the left here means it's reachable via an intra-area path. Router 1 can reach Router 2 directly within Area 1. A cost of 10 to get there. Next hop is Router 2's interface address, and iOS tags it explicitly as ABR. No ambiguity whatsoever. The last piece of this lab, let's see what these Type 3 LSAs actually produce in the routing table. Okay? So what we're going to do is on Router 1, we will do a show IP route, and then we'll do OSPF, just to make it succinct here. Okay? And we'll actually do the same thing on Router 3. So show IP route, OSPF. Okay? Two types of OSPF routes here. All right? The ones marked just O, these are intra-area routes. Learn from Type 1 and Type 2 LSAs within Area 1. Router 2's loopback, for example, is one of those. Okay? So as you can see here on Router 3, we have those two types, and they are different from one another. Okay? But then there's the these ones, the O and the IA, right? Without doing it. So the O and the IA. That's O inter-area. Every OIA route is, or in this table, was put there by a Type 3 LSA from Router 2. Okay? 10.0.23.0, that's the link between Router 2 and Router 3. 3.3.3.3, that's Router 3's loopback. 192.168.3.0, Router 3's simulated LAN, or local area network. All of them are coming from Area 0. All of them arriving via Router 2's Type 3 LSAs. All of them pointing via Router 2 as the next hop. The trail is clean. Type 3 LSA OIA route, next hop is the ABR. If we flip over to Router 3 real quick, Serial 1's prefixes show up as OIA routes here, all sourced from Router 2. So as you can see, 1.1.1.1 would be sourced from Router 2 because that is multiple areas, and that's Router 1, obviously. But it's symmetric. It's beautiful. Router 2 is in the middle doing the work for both sides. So hopefully this lab has kind of given you some context in how this works in reality. Okay, let's talk about the name because it causes the real problems. Summary LSA, most people hear that and think route summarization. Like the ABR is aggregating a bunch of /24s into a /22 or something. Fewer routes, smaller routing tables. That is not what's happening. By default, the ABR creates one Type 3 LSA for every individual subnet it learns about. If Area 1 has 10 prefixes, Router 2 sends 10 Type 3 LSAs into the Area 0. No aggregation, no combining 10 individual advertisements. You can configure the ABR to do actual route summarization. The command is area x range, but there is a deliberate manual configuration. It's not what Type 3 LSAs are all about. So what does summary mean then? Think about it. Think about what the ABR is actually doing. Area 1 has a full topology, router LSAs, network LSAs, adjacencies, link types, interface costs. The ABR runs SPF on all of that, or shortest path first. Figures out every reachable prefix and cost to get there, and then boils it down to, here's a prefix, here's a mask, here's the cost. It's summarizing the topology, compressing all of that complexity into the minimum information another area needs to route. That's the summary. And one more thing that trips people up, ABR versus ASBR. An ABR, or area border router, connects multiple OSPF areas and generates type 3 LSAs, as we've just learned. An ASBR, or autonomous system boundary router, redistributes external routing information into OSPF, generates what's called type 5 LSAs. These are different jobs. A common wrong answer on an exam is the ASBR generates type 3 LSAs. It does not. The ASBR doesn't touch type 3 LSAs at all. So let's close the loop. The LSA type 3 summary LSA are generated by the area border router, or the ABR, period. And here's the shortened version of why that's true. OSPF uses multiple areas to keep topology information contained. The ABR is the router that sits on the boundary between areas. When it learns about prefixes in one area, it doesn't just forward that topology information. It creates brand new type 3 LSAs that describe those prefixes in a simple format: prefix, mask, and metric. Those LSAs show up in the OSPF database under summary net link states, as we displayed earlier, with the ABR's router ID as the advertising router. In the routing table, they become OIA routes, OSPF inter-area. The ABR generates them. Nobody else can. That's the answer. If you can explain that chain, just recite the answer, but explain why, you're going to be solid on any question that touches OSPF multi-area design. If you want to build this lab yourself and poke around, I have the full router configs in the description. Copy, paste, done. If something wasn't clear or you want to dig deeper on any of this, drop a comment. I do read them. And if this helped, the like button is right there. It actually does help the channel, so thank you. And I hope to see you in the next one.